Okay, number 9. So we're going to do this on the calculator. Here's the equation for the rocket. Now the rocket goes straight up in the air and then comes back down again. This graph here is not the path of the rocket. Rather, it shows the height of the rocket over time. The way they draw it, it makes it look like, well, they shoot the rocket and it went up and it was like it started here and it came down over here. No, they shot the rocket straight up in the air and it came down. Imagine there's no wind, it's in a vacuum or whatever. And maybe they have a little parachute on it or something. Of course, if it's in a vacuum, the parachute won't do any good. But anyway, it comes straight back down again. That's what the rocket is doing. This equation is not the equation of the path of the rocket. It's the equation for the height of the rocket over time. So let's put in the calculator. So we're going to put in negative 16 x squared. We don't have a t. We're going to put in x. Well, we do have a t, but we're not. I'm not going to go into explain anyway. We're not using t. Okay, so that's the force of gravity. And this plus 135x, or t, is the initial velocity. In other words, there was a little rocket, and it just went off, and it gave it initial velocity, but the velocity didn't continue. That was it. Okay, the rocket went off, and now the thing is just continuing in the air, and now and as soon as it takes off, gravity starts pulling it back. Okay, now we want to let's figure out. We can do a little bit of math here to help us figure out what this thing is going to do. If we take here, I'm going to clear this. Minus b over 2a. B is 135. C is 0. In other words, its initial starting point is 0. It starts from the ground, so it starts on the ground. So C is 0. A is negative 16. B is 135. So minus b over 2a is going to be negative 135 divided by negative 32. Okay, so this is going to be the x-coordinate of the vertex. It's the number of seconds that go by until the rocket reaches its maximum height, because that's what the vertex would be. Okay, so I hit enter. So after 4.21875 seconds, or about 4.2 seconds, the rocket is at its maximum height. Now, we don't know what that is. We could plug this number into the equation. In fact, let's do that. That's not hard to do. Negative 16 times, and I'm going to take the answer. I'm going to hit second and the minus key, and that puts my answer right there. And I'm going to square that answer. So I hit squared plus 135 times the answer. Now this is going to give me the y-coordinate of the vertex, because I'm taking the x-coordinate of the vertex, 4.21875, that I just got on my calculator by doing minus b over 2a, and I'm plugging it into the equation. I'm doing negative 16 times the answer squared, the x-coordinate of the vertex squared, plus 135 times the x-coordinate of the vertex. Okay, now here is the maximum height. The maximum height is going to be about 285 feet. Okay, now you're asking, well, all right, I want to make a graph on the calculator. This is really valuable information. I know that the maximum for the window for the y coordinate is going to be a little over 300, and the scale, I know on the x-axis I'm going to go from 0 to a little bit over 8. So I'm going to go to y equals. Here's the equation. All right, I just went over putting that in. Now let's go to the window. Okay, I'm going to make here. Let me do this first. I'm going to do z. I'm going to put it back to the standard window. Okay, I'm going to go to window, and I'm going to put in 0 because why? Why am I putting 0 for x? Because x is a number of seconds. So we can't have negative time, and the rocket takes off at 0 seconds. So we reach 0. The time is 0 when the rocket takes off, and then the time stops when the rocket hits the ground. Now we already figured that it's going to be at its maximum around 4.2 seconds, so it's going to hit the ground around 8.4 seconds. So 10 is plenty of a range, plenty of a spread for my x-axis. Now the minimum, well, we're not going to have minimum height. It's not going to dig a hole into the ground. Now we just saw the maximum is going to be around 284 feet. Now for reasons I'm going to explain in a minute, I'm going to make the maximum 325. I want a little headroom over the graph, and I'm going to show you why. Now the scale, I'm going to make 25. Now what is the scale? The scale is how many tick marks you get on the axes. And it's a good rule of thumb is between, you have the spread for the x-axis is 0 to 10, so the spread is 10, and a scale of 1 is good. So anywhere from 10% to 5% of the spread is a good scale. Now here we go from 0 to 325. I'm going to make the scale 25. 25 is a nice convenient number, and it's a little over 10%, or a little less than 10% of the spread. So that's going to work out real good. And we'll see. Now let's look at the graph. Okay, and here you see the tick marks. Okay, so here's the height at 0 seconds. And then here's the height, here's the maximum height right here, and that's around 4.2 seconds. And then around 8.4 seconds, the height goes back to 0. And we have a parabola. So the axis of symmetry is right through here at 1, 2, 3, 4, around 4.2 seconds. Right here is the axis of symmetry. Okay, now let's, what else can we do with the graph here? Let's use the graph to tell us the maximum height and or the vertex. Okay, let's use the graph to tell us the vertex. Now we have a maximum here. So if I hit second and then trace, I'm in the calc menu, and these are all the things I can calculate on a graph, and here is maximum. So I know this graph has a maximum, I can tell by looking at it. Now, the calculator is going to calculate a maximum within an interval. The calculator doesn't have eyes. It can't look at the graph and see what the heck is going on. You have to tell it where to look. So when you ask for a maximum, it's going to say, well, I want a left-hand marker for where I'm going to look for the maximum. So it needs a left-hand marker and a right-hand marker, and it will look for the highest y value within that interval. Okay, so you want to make sure your left marker is to the left of the maximum that you are interested in finding out. Later on, we'll be looking at graphs that have multiple maximums, called relative maximums. Okay, now it wants a marker to the right. So I hit enter. Now, you see these two markers here. The calculator, here it says the word guess, will calculate an approximate maximum between this x value here and this x value here. Okay, so I hit enter, and it's thinking. And now here is 4.218, so that's what we calculated as the x-coordinate of the vertex. So here's the vertex, 4.218, or you could call it 4.22, you could round a little bit, comma, 284.8. Okay? So here's the vertex. The y-coordinate of the vertex is the maximum or the minimum of the graph. Okay? The x-coordinate of the vertex shows you how much time went by before it reached the maximum. So how long was it in the air? Well, we figured that out. Let me go back here. It was in the air. Here is 4.21875. Let me call that computation back up again. There is the x-coordinate of the vertex. So if I multiply that by 2, took off at 0, that's how much time that it was in the air. 8.4 seconds. 4.2 seconds up, 4.2 seconds down, because it's symmetrical. Let's go look at the graph again here. So we found out the maximum. Now, we can verify our 0 here, but we'd have to modify our graph a little bit. But that's pretty much all we need to do with this problem right now. So I'm going to go on to number 17, because that's the next homework problem. We started with 9, and the next one we're doing is 17. Now I'll do a few of these, and then I will go and see if look at some more word problems, and we'll work on those. Okay, now here's 17. Now, we're going to solve it by graphing, but we're going to do it on the graphing calculator. And by solve, it means find out how many zeros it has and what they are. Okay? So, I'm going to go to y equals, and I'm going to clear the equation out that I had in before, and I'm going to put in, I hit the negative sign, 2x squared, okay, minus 8x, and then it equals 13. Well, I got to subtract that 13 from both sides, so I'm in standard form, minus 13. Okay, now I know that. Now I'm going to use a standard display to look at this graph. So let's just look at the graph. Okay, let's graph it, and I'm going to hit zoom and standard 6. Let's see what it looks like. Okay, so you can see the graph doesn't come close to the x-axis. So this has no real solutions. It has a couple of complex solutions, but no real solutions. And there's no need for us to look any further at this graph. So we've pretty much solved this. Okay. So 18, let's do 18. Okay, so I'm going to go to y equals 18. I clear this out. 2x squared minus 16x, and I'm going to add 30 to both sides, plus 30. I got to put it in equals 0 mode. Okay, so 2x squared minus 16x plus 30. Okay, so I'm going to hit graph. We're in the standard screen here. All right, now you can see I got 2 zeros. So let's go see what they are. Now, using the calc function, it's going to be kind of hard because this is kind of narrowed down. So I'm going to take my window and I'm going to narrow this down. Okay, let's see how that looks. That's a little better. Okay. Let me take a little bit off I'm going to shave a little bit off the y. So I'll go back to window, and I'm going to make this -2, and I'm going to make this 8. And let's see what this does for us. Okay, now you know what? You can see 1, 2. This here it goes through 3. The axis of symmetry is at 4, and then it goes through 5. So the solutions are 3 and 5. You can see it right off the graph. And obviously then this would factor. All right, let's do 19. I'm going to clear this. I want to check 18. Hold on a second. 18. So 18, right. All right. Now 19. Let's put a 19 in. Okay, y equals 2x squared plus 24x plus 72. Okay, now this is another one that probably factors, but let's take a look at that. We've done that. We did that last chapter. Now I want you learn how to use this thing. And I'm going to set my zoom standard. Give it the standard screen. Okay, now what's going on here? Let's look at this for a second. Let me open up this here. All right, and I'm going to do a little writing on here. Okay, so it's 2x squared this pen heavier. So 2x squared minus 16x plus 30. And that didn't do any good. So let's see if this helps. All right, so I'm going to factor a 2 out of everything. So I'll have 2 times x squared minus 8x plus 15. Okay, so this is going to be 2 times I got the wrong problem. Here. Should be doing 19. This is the previous problem. Well, let me go ahead and finish this. So you can see this is going to factor to x minus 3 and x minus 5. All right, now 19, we're going to have 2x squared plus 24x plus 72. Take out the 2. We got 2 times x squared plus 12x plus 36. Now, 36 is a perfect square. Obviously, x squared is a perfect square. The first term is a perfect square once the 2 is factored out. So, does the middle term equal 2 times a times b, where, in other words, does it equal 2 times 6 times x? And it does. Okay, so if you take the square root of the third term and the square root of the first term, multiply them times each other and times 2, that equals the middle term. So this is a perfect square. So this is 2 times x plus 6 squared. All right, so we have a double zero at negative 6, at x equals negative 6. And that's what we see on the graph. 1, 2, 3, 4, 5, 6. At negative 6, the graph touches the x-axis at just one point. When the equation is a perfect square, or has a perfect square factor in it, then you're going to have a double, what's called a double zero, and the graph is going to touch the x-axis at only one point. And so we have one solution. All right. Number 20. Let's look at 20. Clear this out. Okay, minus 3x squared plus 2x minus 15. Okay, now a times c is positive, it's 45. We could rewrite this. We could factor out a negative 1. So let's suppose we had negative 1 times 3x squared minus 2x plus 15. Okay, we would have a positive 45, out of which we were going to try and come up with somehow with a negative 2. It's not going to work. It would never factor. So anyway, let's see what the graph is going to look like. Now we're not going to see this graph probably because of the plus 15. So let me change the window, and I'm going to make the window. Let's set the y max to 25, and let's see how that helps. If we can see the graph now. I should have made it lower. I forgot. I had factored the negative 1 out over here. So I should make the y min negative 25. And I'll make this 5. Shift it. Okay, and then we see the graph. So there are no real solutions for this graph. It has 0 real solutions. All right, so let's look at 20. Now we're going to estimate the roots to the nearest tenth. So with 22, go to y equals, I'm going to clear it, x squared plus 2x minus 9. Okay, and I'm going to do a zoom standard. Okay, now we're going to use the calculator to estimate the zeros. So if I hit second and trace, there's a calculation feature for 0. Now this is going to work similarly to finding the maximum or a minimum for that matter. It wants me to move the cursor, move the blinking X to the left of whatever 0 I want it to compute. Then I'll move it to the right. I want to move it to a left-hand X coordinate of the 0 that I want to compute. Then I'll move it to a right-hand X coordinate for the 0 I want to compute, and it will compute a y value for 0 that's in between those two x values. So I'm going to move the cursor to the left. Now, what am I looking for? With a 0, I'm looking for when the y value is going to switch from negative to positive. All right, now the y values are positive, so I know that my x value is to the left of the 0 that I'm interested in. So I can hit enter. Okay, so there's my first marker for finding the 0 in a particular interval. Now I'm going to move it to the right. My y values are now negative. I'm going to go a little bit further. And so this x coordinate is clearly to the right of the 0 that I'm interested in computing. So I'm going to hit enter. So here is the interval on the x-axis within which the calculator will estimate as close as possible for a 0 y value. So it'll find the x value that comes as close as possible to a 0 y value. Okay, so I hit enter. And so at approximately negative 4.16, y equals 0. Okay, so there's my first zeros. I'm going to take a picture of that. We can look at that later on. Okay, so there's my first 0. Now I want to find this 0 over here. There's 2 zeros. Okay, in other words, there's 2 x values for which y equals 0. And so I'm going to hit second and trace, and I'm going to hit 0 again, 2. And now I'm going to have to go real far. Now, okay, now I'm getting close to, I'm still to the left of the x coordinate of the 0 that I'm interested in. How do I know this? Because y is negative. So I know that I'm to the left of it. So I'm going to hit enter, and I can set the left-hand side of the interval within which the calculator will give me the x coordinate for the 0. Okay, now y is positive, so I know I'm to the right of the 0 that I'm interested in. So I hit enter. So here's the interval on the x-axis within which the calculator will estimate the x coordinate of this 0. So I hit enter. And so at approximately 2.16 on the x-axis, y equals 0. Let me take a picture now. Normally, you would write this. This is what is going to go into your answers for your homework. Okay, this is what you're going to write down. When x equals negative 4.16, y equals 0. When x equals 2.16, y equals 0. Okay, so that is the answer to, what is this? I don't remember what problem I was working on. For 22. Okay, so now let's do 23. And so I'm going to clear this. And 23 is x squared minus 4x minus 20. Okay, let me double check. X squared minus 4x minus 20. Okay, now I'm going to, I think I'm on still in the standard window. Let me just zoom standard. Let me just double check to make sure I'm in zoom standard. So I hit 6. Okay, now I don't see the bottom of the graph, which in some ways it's a problem, in some way it's not. Okay. Anyway, I can with the graph the way it is, I can still estimate these zeros. So I'm going to hit second and calc, and I'm going to hit 2 for 0. Okay. Now I can't see the cursor, so I know if I hit it left, there it is. Okay. Now y is positive, so that I know that the x coordinate is to the left of this 0. So I hit enter. So there, now I've got to move the cursor down the parabola, and now I know, since y is negative, I know that its x coordinate is to the right of the 0. So I hit enter. So within this interval on the x-axis, the calculator will figure out the x coordinate as close as possible that goes with this 0. The calculator says it's guessing. Well, it's a lot better than guessing. Okay, so approximately negative 2.89, call it negative 2.9, y equals 0. So let me get rid of these. I'm going to get rid of these guys, and I will put this one in there. Okay. All right, so now we got to find this 0 over here. So I'm going to hit second and trace again, and I'm going to put in 0. And now I'm going to go to the right, and I'm going to look for the cursor coming up from the bottom on the right-hand side of the calculator. You see it's at negative 23, and it's negative 22, negative 19. It's coming, it's coming. Okay, it'll be in sight. Here it is. Okay. Now y is still negative, so I know that this x-coordinate is to the left of this 0 here. So I hit enter. Now I'm going to move the cursor. So now y is in positive territory, so I know that the x-coordinate that goes with this y value right here is to the right of the x-coordinate for the 0. So I hit enter. That's what I want. Within this interval, the calculator will find on the x-axis the x-coordinate as close as possible that goes with this 0. I hit enter. Okay, about 6.9. So let me take a picture of that. Okay, so that's your next answer. I believe that's the answer for 23. Okay, 24. I'll do a few more of these. What am I doing? Okay, I'm going to clear this. 24. X squared plus 3x minus 18. Okay, so x squared plus 3x minus 18. So let's graph it. Okay, more of the same. Now this looks like we might have integers. Yeah, in fact, this thing factors positive 6 and negative 3, and so this would become, for 24, this factors too. Thought we would be estimating them. So this would be x squared plus 3x minus 18. Looking for factor pairs of negative 18 that combine to equal 3. Well, obviously, that's going to be plus 6 and negative 3. So the two solutions are negative 6 and 3. As you can see here, this is negative 6 and that's 3. Okay, let's look at 25. Let's see if it factors first. So 25. We got 2x squared minus 9x plus 8. Okay, so we're going to have a positive 16. Let me make some space here. So we're looking for factor pairs of negative 16 that combine to equal negative 9. Okay, obviously we're going to have two negative factors. So we got negative 16 and negative 1. Obviously that's not going to work. Okay, negative 8 and negative 2. That's not going to work. And negative 4 and negative 4, and that's not going to work. So sorry, Charlie. We're not going to make it, so it doesn't factor. So let's put this guy into the calculator and figure out what's going on. So we got 2x squared minus 9x plus 8. All right. So let's graph it and see what we got. All right. So we're going to have to use the calculator to come up with these, estimate these zeros. And so I'm going to work with the window a little bit here. So I'm going to make this 0 and this 0. I want to only deal with the first quadrant. So I'm making x min and y min 0. Let's take another look at it. Oh, that wasn't too smart because I got no space underneath here to work with. So I got to go back to my window, and I'm going to go down and make the x, I make the y min, let's say negative 3. But I want to cut down on the x max. Let's make this, let's see if 7 works. So let me graph this again. Okay. All right. Now that's not too bad. All right, so let's do second and trace, and I'm going to find the 0. And so I always like going from left to right. I guess I'm just too. All right, so I'm to the left of the left-hand 0. I hit enter. Okay, now you won't be able to see the cursor too well. I should have left more room underneath, but you can see that y is negative, so you know that you're to the right of the 0, of the x-coordinate of the 0. So I hit enter, and enter again, and I'm going to go over here and get rid of these guys. Okay, and so I'm going to take a picture of this, and then let's get the other 0. So I'm going to do second and trace, and 2 for 0. Okay, now I'm getting, so you can see that cursor is getting close, so I hit. It's still, y is still negative, so I know I'm to the left of the right-hand 0. And so then I hit enter, and then I move the cursor, and now I'm to the right of the right-hand 0. So I have my interval, I hit enter, and there's the other 0. Okay, and so this is for, what number was this? This was 25. So let me check 25 real quick. Okay, so we got about 3.3 and 1.2, and that's looking good. Okay, so let's do 26. Now let's see if 26 factors. 26. So we got 3x squared plus 2x minus 7. Okay, let me double check. 3x squared plus 2x minus 7 equals 0. Okay, so we're going to have negative 21. So we're looking for factor pairs of negative 21 that are combined to equal positive 2. Okay, I'm not real optimistic about this. 21 and negative 1, 7 and negative 3. And I think that is all she wrote. Okay, so let's put this into the calculator. So I'm going to clear this. And so we have 3x squared plus 2x minus 7. Okay, this is 26. Let me double check. 3x squared plus 2x minus 7. Okay, now I'm going to go zoom. Let's go zoom standard and see if we can see anything. Okay, all right, there's our zeros. All I really need to do is focus in on the x-axis. So narrow down the x-axis a little bit. So I'm going to go to Window. So I'm going to make this -5. And I'm going to make the max 5. And let's see what that does for us. And I hit Graph. Okay, now we've got some breathing space. And the other thing I'm going to do, I'm going to hit Window. I'm going to make the Y min bigger. I'm going to go -12. Give me some more space so I can see the numbers as I'm going through them. Well, that's not what I meant to do. But to put in Y min is -12, not -2. Okay, let's try it again. Hit Enter. Let's try it again. Okay, that's better. All right, so second calc 0 for 2. Okay, I'm going to do the left-hand 0 first. So let's move over. Okay, Enter. Okay, get the right-hand mark and make the interval. Okay, guess. All right, and I'm going to get rid of these guys and then take a picture. Okay, so for number 20, I just want to check the answer for 26, make sure we got -1.9. Okay, let's get the other one. Oops. Second, trace, 0. Okay, now we're going to move left. Okay, Enter. Go to the right. Enter, Enter. Okay, so the other zeros are about 1.23, so I'll take a picture of that. Okay, there's the zeros. All right. 27. All right, let's check this out. 27. Okay, so we're going to have x squared plus 5x minus 25 equals 0. Let's check this out again. I add x squared to both sides. I leave the 5x where it is, and I subtract 25 from both sides. Okay. So I'm looking for factor pairs of -25 that combined equal 5. Not a snowball's chance. Okay. So we're going to have to use the calculator. So y equals, I'm going to put in x squared plus 5x minus 25. Now, let's double check. X squared plus 5x minus 25. Okay, this is for number 27. And let's do a zoom standard, 6, see what it looks like. Okay. All right, we can work with this. This will be all right. Looks like these are pretty close. Okay, so I'm going to do a second trace, 2 for 0. And I'm going to I'm really down here. Okay, if you hold it down, it will, all right. It came all the way up to here. Okay, hit Enter. Now, I'm going to move it down. So now it's below the 0 and to the right of the x coordinate. I hit Enter, Enter again. Okay, so here's my first 0, -8.09. Let me get rid of this. And this, okay. So this is 27. Okay, and let's get the other 0. So I'm going to hit second, trace, and 2 for 0. Okay, now I'm going to just push the right arrow and hold it down. And it's going to, I don't know if that'll work on your calculator or not. It works on mine because I'm on the computer. I think it'll work on yours. Okay, there it is. Okay, the y coordinate's negative, so I'm going to the left of the 0 on the x-axis. Now I'm going to go to the right. Now I'm above the 0, so I know this x coordinate is to the right of the 0. I hit Enter, Enter again, and 3.09 is my other 0. So I'll take a picture of that. So there's the two zeros. Which one did I? 8.09, 3.09. Okay, let me get rid of this. Okay, so there's the two zeros right there. Okay, negative 8.09 and 3.09 are the two zeros. Okay, next, 28. Okay, now a little word problem here. Another thing with the, okay. Now, how long is the ball in the air? Okay, let me go to the next page so I can see this whole problem. Here we go, 28. All right, so the ball is 3 feet off the ground when Sophia hits it. And the velocity that she hits it with is 47 feet per second. And gravity is pulling it down at negative 16 t squared. Now, the thing that is not taken into consideration here is the angle at which the thing is taking off and all of that. Now, remember, this equation is simply for the height of the ball over time. It has nothing to do with the actual path of the ball. All right, so let's use the calculator here. Let's do a little spade work. Okay, so A is negative 16, B is 47, and C is 3. Okay, so our starting position is 3. Minus B over 2A, which is the x-coordinate of the vertex. In other words, how many seconds elapse until maximum height will be negative 47 divided by negative 32. Okay, big surprise. All right, we're always dividing. A is negative 16 whenever we're dealing with this gravity stuff. Okay, so how long is the ball in the air? Well, here's the vertex. This is the maximum height. So if you multiply this, okay, if you multiply this times 2, you're going to get, this is the amount of time that elapses from when it's 3 feet off the ground until when it's at 3 feet above the ground again. Okay, so that's not exactly all the time that's in the air. It's going to require a fraction of a second to hit the ground. Okay, but we do know that 2.9375 seconds is the number of seconds that it spends in the air from 3 feet in the air to 3 feet again. Okay, so we'll need the calculator to tell us precisely when it hits the ground. Okay, so we're going to go to y equals, we're going to clear this out. But here, let me go back to here again. Okay, so we know that the whole number of seconds that elapse before it takes off and it hits the ground again is 3 seconds. So this will be very valuable to us in setting up our graph. And I hit plot. Okay, so we're doing negative 16 x squared plus 47x plus 3. Okay, now let's look at our window. Okay, obviously we're going to start at 0. Now, we don't want to set it to just a 3 because we want to go a little bit, we're going to have to do some calculations there. So let's make it 5. Okay, the scale, let's make the scale, just for the heck of it, let's make it 0.25, or let's make it 0.5. Okay, now we want to go a little bit below the y-axis, even though we're not going to go, because we want some space for our calculations. Let's see how negative 10, let's leave it at negative 10. Let's see how negative 10 works out. But the max is going to be up here. It's going to go up in the air a bit. And let's go back. Actually, let's go back to our calculator. Okay. Here is 1.46875. I want to do this. I want to go back a little bit. Okay, get our answer. Okay. So here's the answer. Now let's calculate the maximum height. Okay. So we're going to take negative 16. Oops, I forgot the negative. Negative 16 times the answer squared, okay, negative 16t squared, plus 47 times the answer, plus 3. Let's double check. Negative 16 times the x-coordinate of the vertex plus 47 times the x-coordinate of the vertex plus 3 will give us the maximum height. So let's hit enter. The maximum height is only 37 feet. Okay, so let's go back to our window. And so let's make the y max 50 feet. Okay, and let's set the scale to 5. All right, so I hit graph. Okay, this is not bad. All right, this is not bad. Okay, so we want to know at what time the ball hits the ground. That's right here. Okay, so we want to compute this zero. So here it is, 3 feet off the ground. The ball starts out 3 feet off the ground. That's the initial height. Okay, but it's going to hit the ground, assuming nobody catches it, although it seems like somebody ought to catch it. But anyway, it was hit really, really, I don't know if that's very hard. Anyhow, forget it. Second and trace, calc, we want the 0, 2. Okay, now, are we to the left of the 0? Yes, we're to the left of the, we're interested in this 0 right here, because this is 0 where this is where it hits the ground. So I hit enter, and now I want to get, now the x is going to go over the numbers, but you can see y is negative. It's sort of hard to see. I should have left. You know what, let me do this. I'm going to make the y min negative 20. So we have plenty of room down there to see what the heck, to see what our numbers are doing. Okay, so let's do this again. I'm going to do second and trace, and I'm going to do 2 for 0. Okay, there I am to the left of the 0 I'm interested in, left bound, so I hit enter. Okay, now I hit the right hash mark. Okay, now you can see I'm to the right of the 0 that I'm interested in, so I hit enter. And so 3 seconds. Okay, 3 seconds. All right. So how many seconds before it hits how long is the ball in the air? 3 seconds. Okay, now what did we compute? Let me get back, as the number of seconds the ball was in the air. It was twice 1.46875, which was 2.9375 seconds. All right, so it was in the air, you know, a few 1/100ths of a second longer. Okay, that takes care of 28, and now we're doing 29. Okay, this is the same old song with the same old story. So how long? Okay, it starts on the ground. Okay, the starting position is so how long until it hits the ground again? Okay, so well, this is all we're going to do is take the vertex, because h is 0, okay? And so let's just get the vertex again. Let me clear this. Okay, so the vertex is going to equal minus b. B is 122. C is 0. The initial position is 0, so there's like the thing starts on the ground or whatever. Okay, so we're going to do minus 122 over 2a divided by. Oops, I forgot my second 2. Divided by negative 32. Okay, so that's the top. That's the top. That's how many seconds it takes to reach the top of the Tower of Terror. Okay. Now they're not asking us to compute the maximum height. We could easily compute that by simply multiplying this number by squaring this number, multiplying it by negative 16, and then adding that to 122 times this number. And that would give us the maximum height, and we would have the vertex. But this doesn't ask us that. How long till they return to the bottom? Well, it's 3.8 seconds to the top. Multiply that times 2. Okay, after 7.625 seconds, you're back on the bottom. Okay, now let's, you want to use the graph to do this. Okay, let's do it with the graph. So we're going to do y equals. I'm going to clear this. Now, since we're going to do this with the graph, this is a little backwards, but let's compute the maximum height. It will really help. It's not hard to do, and it will really help us to figure out how to set up the graph. So negative 16 times the answer squared plus 122 times the answer. Okay, and then C is 0, so we just hit enter. Oh, there's our maximum, 232 feet. Okay, so the maximum is 232. So we'll go to y equals, and we're going to put in negative 16x squared. I don't know why I'm bothered ever. Plus 122t x. Okay, now let me get out of here for a minute. I'm going to take a picture of this. Okay, there we go. Makes it so much easier. All right, so let's go to window. And so we're going to set, we will like 0 for the window. Now it's up in the air for 7.625 seconds. So let's make the maximum 10. Okay. And the scale, let's put the scale back down to 1. Okay. Let's keep that negative 20 there. Now let's make it negative 50 because we're going a lot higher. And so let's make this 300. And let's make the scale 25. Okay, and let's graph it. Let's see what we get. Okay, not too bad. But I'd like a little more room at the bottom. Let's make this negative 100. Just so we can see the numbers when we're looking for how much time elapses when we hit the bottom. So here's the graph. Okay, so we want the 0 right here. So I'm going to hit second and trace, calc, 2 for the 0. All right, am I to the left of the 0 I'm interested in? Yes, I am, so I hit enter. Okay. See, by giving myself a lot of space at the bottom with the Y min, then I have room to see the numbers and the cursor. Hit enter and enter again. Okay, and there's my, so at after 7 seconds, the height of the thing is back to 0. All right. 28, 29. The next problem is 37. Let's look at 37. Okay. Okay. Let's more of this same here. Let's do a little bit of work though, prep work. Okay. Let's get out of here and let's clear this. And let me get to, all right. So Stephanie is not going to be in the air very long. Okay, minus B, not even her, she's going to reach her maximum height at less than a second. So A is negative 16, B is 30, and C is 10. She starts at 10 feet high. Okay, so we're going to take minus B, minus 30, over 2A, which is negative 32. Okay, so there's her, that's the x-coordinate of the vertex. That's her maximum height. Okay, so she's not going to get very high. About, we can figure it out. Let's find the maximum height right now. Negative 16 times the second answer. Okay, second and minus, okay, we're going to square it. Okay, plus 30 times the answer, plus 10. So this should be the y-coordinate of the vertex, 24 feet. Okay, so after about 1 second, she's 24 feet in the air, and then she's coming back down. Okay, and then let's see. All right, so let's just take a picture of this because we're gonna use this. Okay, let's get rid of some of this stuff. Let's get rid of that and this. Let's get rid of this and this. Okay. All right. So let's go to y equals and negative 16x. Oh, let me clear this. What am I doing? Negative 16 x squared. Okay, plus 30x plus 10. Okay, how long is she in the air? So we're going to find the 0. Okay, so let's figure out our window. So we know her maximum. She's in the air like a couple of seconds. Okay, so let's make this 4. Okay, let's make this a half, 0.5. All right. Okay, now the y min, let's make this negative 5. Or let's make it negative 10. Let's make it negative 10. We want a lot of room under it. We're going to have to figure out, we have to find the 0 where she hits the ground. And let's make this 50. And let's make the scale 5. Okay. And then let's graph it. Let's see what we got. Okay, so there she's in. Boom. Kabooey. She hits the ground. Okay, so let's find, what we want to know is how long she's in the air. Well, we know that. We already figured that out. Okay? But let's use the graph to find it out. So I'm going to do second and trace, and I'm going to calc the 0. And I want to do the 0. So am I to the left of where I want to be? Yes. Do I have enough room at the bottom? Let me put some more room at the bottom. Let me go to the window, and let me make this negative 25. I want to make sure I got enough room under there. Okay. So I'm going to do second and calc the 0, 2. Okay, I'm to the left. I hit enter. Okay, now when I move below the line, I can see the numbers down here. Okay, enter, enter again. So after 2.16 seconds, I'm going to take a picture of this, which matches what we have here. Well, we didn't multiply that by 2, but that's obviously that's what we're going to get. Oh, no. This is more than twice this because she started at 10 feet in the air. So it takes her more than twice this amount of time. This is if you double this, that gets her back to 10 feet off the ground. It takes her 2.16 seconds to hit the ground. Okay, so let me take a picture of this. Okay. This is, let me double check this, 37. Okay. All right, great. Okay, when will she reach a height of 15 feet? Okay. Okay, how are we going to do this with a graph? Well, 15 feet is a y value, right? Okay, here's our maximum. There's a couple different ways to do it, but we can go to y equals, and we go to y2, and we can put in a horizontal line of 15 feet, right here, 15. Bingo. Let's hit graph. Okay, she reaches a height of 15 feet almost right away. She's going to reach 15 feet on the way up, and she's going to reach 15 feet on the way down. Now, so what we're looking for now are intersections. Okay, so I'm going to do second and hit the calc, trace for the calc menu, and now I want intersections, 5. Okay, now I'm going to arrow over to the left. Now notice which graph I'm on. Notice I am on the parabola. I'm not on the horizontal line. Okay. Okay, now I want to get to the, all right. Now, I want to get this intersection right here. Okay? So I hit enter. And as for the second curve, it's going to call both lines curves. I hit enter again. Now it's going to give me the intersection. So right here is the intersection of these two lines over here. So at 0.18 seconds, approximately, she's at 15 feet. Okay? All right, now she's going to go up, reach her maximum, and then come back down again at 15 feet. So we got to find the intersection over here. So here I got to hit second and trace again. I got to do another intersection. Oh, I didn't take a picture of that intersection. Darn it. I apologize for that. Hope you took that down, or otherwise, I'll get the other one anyway. So number 5 for intersection. So, oh, there's the first intersection. So let me take a picture of this. Or not. Let me go to the left. Okay. I'll do it again. Enter. I'm going to go to the right. No, sorry. Second curve. I hit enter. And now it's going to guess it. Okay, so here's the intersection. So I take a picture of this. Okay. All right. Now, I'm going to run this again. Second, hit the trace key. I'm in the calc menu. Intersection number 5. I'm going to arrow over to the right. Okay, now once I'm in the vicinity of this intersection, here's all I have to do. I'm near the second intersection I'm interested in. I'm going to hit enter. There's only 2 curves. I'd enter and then enter again. And it gives me the second intersection. I take a picture of that. Okay, so at about 0.185 seconds, she's at 15 feet. And then she goes up. She reaches her maximum at 0.9375 seconds. And then at 1.69 seconds, she's at 15 feet again. And then she hits the ground at 2.16 seconds. Okay. All right, to reach bonus points in the competition, you must reach a height of 20 feet. Will Stephanie earn bonus points? Well, let's look at these pictures again. Okay. Here we go. All right, we know her maximum is 24 feet, so she's going to reach it. But let's use the calculator to tell us if she reaches 24 feet. So we're going to do second, hit the trace key, and we're going to go to maximum number 4. Okay. Now, we computed it by hand to find the maximum, namely by finding the y coordinate of the vertex is the maximum, but now we're using the calculator. So we hit enter. Now I'm going to go to the right of the maximum. Okay, and as soon as I see him on the down slope from the maximum, I hit enter, enter again. And you can see that the maximum is at y equals 24. So let me take a picture of this. There's all the information that we got off the graph for this problem. Okay, so she gets the bonus points. All right. So that was 37. We got 44. Let's see what 44 is all about. If it's something you already know how to do. Write a quadratic equation that has roots. Describe one double root. That would be any perfect square. One rational root and one integral root. Okay, here's how you do this. Well, you know what? I'm going to leave you guys to figure this out. Okay, 2 distinct integral roots that are out of opposites. This is a challenge. Okay, do the same thing with the challenge. You're going to figure this out on your own. I'm going to make you guys do this. 47 to 50 is review. Okay, so all right, we're done. Enough. Oh my God, this went an hour. I'm very sorry. Just skip the parts. Well, anyway.